Hi there. I've always been captivated by remotely operated vehicles, or ROVs, like the kind used to explore sunken ships or to handle objects suspected or known to be dangerous, such as explosives. When a friend told me about Arduino, a powerful prototyping platform, immediately I wanted to start applying its potential to the ROV ideas kicking around in my head. A quick Google search uncovered some projects that were very similar to what I wanted to do, but nothing quite the same. Nothing that communicated over a Wi-Fi network and sent force feedback information. This is my Arduino Wi-Fi Mini. It can be controlled with a PS3 or Xbox 360 controller, or a Logitech G27 steering wheel, or any other controller that can be read and manipulated with Processing's Pro Control library. It only took me a few minutes this morning to configure this Logitech Rumble Pad to work with the car. Now I'll show you the controllers working with the vehicle. I put the Mini up on blocks to keep it from driving off the end of the table. First I'll show you the PS3 controller. This left joystick handles the speed. The right joystick handles steering. The driver I have for the PS3 controller recognizes these paddles as buttons. If it recognized them as sliders, I'd use them for speed control. So instead, I just use them to direct the camera. Pressing both paddles at once causes the camera to center. This right button pad I've reserved for special functions like steering and camera servo trim. I also don't have any FPV goggles yet, so I implemented a feature I call Auto Camera. When activated, the camera will follow the steering movement. That's handy for when you're going around corners at speed. And now the Xbox 360 controller. I've configured it very similarly to the PS3 controller, except these paddles at the back are used for speed control. The right joystick handles the steering. Right button pad are special functions like auto camera. And the left joystick is now used for the camera if I want to handle the camera manually. And I can either move quickly or slowly. Pressing the left joystick down will cause the camera to center. And here's the Logitech Rumble Pad. It's very similar to the PS3 controller, except you can select two input modes with a toggle switch at the back here, either direct input or X input mode. In X input mode, the pedals at the back act as proper sliders, so I use them for speed. When in direct input mode, the sliders act as simple buttons, but the rumble function works. In the case of the G27 steering wheel, the pedals, which are under the table at the moment, control the direction and speed. And you might have guessed that the wheel controls the steering. Now I'd like to demonstrate force feedback working with the wheel. If I apply a small force, there will be a small reaction in the wheel. If I apply a big force, the wheel will respond more dramatically. Inside of the vehicle, I've mounted an Arduino Uno with a Wi-Fi shield on top of it. So the Wi-Fi connects to the Wi-Fi access point. Processing runs on a computer, either a PC or a Mac, and reads the controller inputs and then sends instructions to the Wi-Fi via UDP packets. The Wi-Fi Mini also sends UDP packets back to processing. That'll contain information for things like force feedback. To obtain force feedback, I tried two approaches. First, I tried mounting a potentiometer on the car's body. And then I attached it to the steering linkage. I then programmed a calibration routine into the Arduino. It would record the pot measurements at each degree of movement given the steering servo. Then, when driving, any difference between the immediate measurements and those recorded at calibration time would represent a force on the steering linkage. Unfortunately, it didn't work very well, and for a few reasons. So I tried a 3-axis accelerometer. I mounted it in the front bumper of the vehicle. The Arduino takes a high number of readings per second and averages them. If the immediate reading deviates from the average, a designated amount, it registers as a force worth reporting. The amplitude of this deviation is directly correlated to the resulting controller rumble. Earlier, I had the wheel set up and was driving around the house. Here's a quick clip of my testing. Even in its limited state, the feedback works quite well. It manages to enhance the driving experience quite a bit. I hope you liked my Arduino Wi-Fi Mini, and if you did, be sure to check out my blog where you'll find a post explaining everything in a lot more detail. Thanks for watching.